Hi everyone. This is a really quick review on factoring quadratic equations. Nothing new here. I'm just going back over the three different types of quadratic equations that we've seen. And when you are faced with a problem and it doesn't specifically tell you which method of factoring to use, how you can decide what kind of quadratic you have, whether it's a general trinomial, another trinomial, or a difference of squares, and then decide, what is the fastest way to factor this? So what method will I use to factor it? Okay, so that's all I'm doing here. It's just doing a quick review. So you can see here, we're looking at your 7.5 notes. And this is part 4 of your 7.5 notes, right at the end, the last page. Okay, and so here's just a few different quadratic equations. I can tell they're all quadratics because they all have exponent 2 on the x, so they all have a degree of 2. And what I want to do here is just recognize what kind I have to make that decision on how I'm going to factor it. We always want to start every single time with looking for a GCF. And if there is a GCF there, we're going to factor it out. Okay, so first I check, can I factor out a GCF? If the GCF is greater than 1, okay, or anything other than 1, factor it out. Do that right away because that's going to simplify the process for you. Okay, that number that you factor out, okay, that GCF will become the A value. So the GCF will become, okay, the A value, okay, when you write it in factored form. And that value doesn't affect the roots when you're trying to solve for the roots in the end. Okay, so the A value does not, so we can say and, okay, this number, this value, A, doesn't affect okay, the roots. So when you get it to factored form and you're setting each set of brackets equal to 0, that number that you have out in front, if you did pull out a GCF, isn't going to make any difference, okay, to the values of x. So x is still going to be equal to something. If you have two roots, you'll have two different values of x there, and that number that you pulled out front really does nothing at all, okay, when you're trying to figure out what those two roots are. So let's go ahead and just quickly, I want to review then the three types of quadratics that we've looked at so far. Can fall into three general categories. So we could have a general term, trinomial. So if we have three terms, general term, okay, trinomial. Trinomial means that it is an equation that contains three terms. So y is equal to, let's say, x squared plus 3x plus 2. There's a general term trinomial. Why do we call it general term? Because that number, the a value here, number in front of the x squared is just a 1. So when a is equal to 1, we can use our fast method. And that fast method is where we're just looking for two terms that give me a product equal to the last term. Okay, so some number times another number equals c, and those same two numbers are going to have to add together to give me my middle term b. That's the fast method, and then whatever those numbers are, we immediately can write them as a product of binomials. Okay, the second method that we use is factoring by grouping, and that's when we have any other trinomial. Okay, so, and by the way, this method of factoring by grouping, it works for all quadratics that are factorable. But how would I know that I have to use factoring by grouping and I can't use the fast method? Well, if the number in front of the x squared is not 1. Okay, so for example, if I had something like let's say, 15x squared plus 13x plus 2. Okay, so again, first I start with looking at my GCF. If I can't factor out a GCF that leaves me with a general term trinomial, then I can't use the fast method. So here I've got to factor by grouping. Okay, and remember that factoring by grouping is where we split that middle b term into two factors, and then we group. We'll have a total of 4 factors. We'll group the first 2 and the last 2, and then we'll continue to factor those. Okay. Finally, then the third special case is where we have a difference of squares. So this is a quadratic equation that only has 2 terms, and both those terms are perfect squares. Okay, so for example, y is equal to 9x squared minus 49. Okay, there's a difference of squares. I recognize it right away because there's only 2 terms. These are binomials. And 9x squared is a perfect square. Okay, it's 3x squared. And here the number 49 is 7 squared. And so I have a difference of squares. And again, difference of squares, I'm looking for the square roots of each of them. And I can simply write it as a product of binomials where I have, okay, the sum of the 2 squares, so 3x plus 7, okay, times the difference of those squares, square roots. Okay, so it looks just like that. So those are the three methods that we use, and really methods 1 and 3 are these are just fast. They're faster because they're just skipping some steps. Okay, this works for all, but it is more work, and so we can save ourselves some time when we recognize a general trinomial or a difference of squares. Let's go ahead then and just complete our notes. So when you're looking at it, any of these quadratics, just going through a process, the first thing I'm going to check is, if do I have a trinomial or a binomial here? So for the first one, I see that I have 1, 2, 3 terms. So this is definitely not a difference of squares. It's a trinomial. And what kind of trinomial is it? Well, let me look at the number in the front of the x squared, my a, and it's just a 1. Okay, so a is equal to 1. So that means this is a general term, or call it general trinomial. So I can use the fast method that I learned. Okay, you could also factor it by grouping, but the fast method would save me some time. Okay, the second one, right away, as soon as you have a number that's an a value that isn't equal to 1, before you assume that you have to factor by grouping, you should check for a GCF. Okay, and if you look at this one, I do see that 2, 6, and 4 all have a common factor of 2. Okay, so if I were to factor that 2 out, that leaves me with x squared plus 3x plus 2. Okay, and what I have right here then, here inside, okay, the number in front of the x squared is a 1. And so we could say that inside those brackets, we actually have a general trinomial. So I could just leave that 2 outside and factor the inside using a fast method. That absolutely works. Okay, you could also use factoring by grouping here, and that would be fine. Okay, C, let's have a look at C. Okay, again, I see that a is not equal to 1. So, but before I assume factoring by grouping, I should just check a GCF and just see, is there any term that's common to 15, 13, and 2? Is there any number that I can divide 15, 13, and 2 all by? Well, the smallest number that will go into 2 is going to be 2 or 1. But I can't divide 13 by 2, and I can't divide 15 by 2 to give myself a nice whole number. So the GCF here is just 1. Okay, so a in this case is not equal to 1. It's equal to 15. So I have to use, this is what we call an other trinomial. It's not a general term trinomial. And so we're going to use factor by grouping. So we're going to split that middle term in half. figure out what those two terms will be, and then group them. Okay, the very last one here, right away when you see two terms, that's a binomial. Okay, this is a binomial. There's only two terms. So right away I do want to be looking for a difference of squares. Immediately, if you recognize that 225 is a perfect square and 121 is a perfect square, then you can go ahead and just get started right away. This is definitely a difference of squares, but just like always, we should be checking for a GCF because sometimes the difference of squares is hidden. And once we factor the GCF, it's very clear. We can see that we have two perfect squares. Okay, so in this case, you could try some different numbers that go into 225 and 121, but you're not going to find any common factors except one. So, and it turns out that they are both perfect squares. Okay, so this is a square and that is a square. And so this one is 15x squared. Okay, and this is 11 squared. And so this is difference of squares, and I am going to can use my FAST method. Okay, so really all I wanted to do here in the review is just go over a couple of examples where, you know, it's not, you have to make that decision on how you want to factor it. And again, as I say, factoring by grouping will work, but it's more time consuming. So we do try to save ourselves time when we have either general term trinomials or difference of squares. I'd like you to try part 4 now of your 7.5 worksheet. And all you're doing on this last part is exactly what we did here, just recognizing the type of trinomial and making that decision on how you're going to factor it, FAST method or factor by grouping. Thanks for joining me today, and good luck.